Okay, so what we're going to do in this bit is we're actually going to look at the general case, and I'm going to apply that general case to the quadratic case, and I'll show you what I mean when I do the quadratic. So let's start off with the general case. So the general case is for any polynomial, whatever you have, whatever the degree is, this will work. Okay. So the sum of the zeros for this general case, so the sum of the zeros is equal to alpha 1, so plus alpha 2 plus alpha 3. So if you've got all of these different zeros, then this is the same as taking the second coefficient of your polynomial and dividing it by the first coefficient. Okay. Next we've got is the sum of products of pairs, and that's equal to alpha 1, alpha 2 plus alpha 1, alpha 3 plus da 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 until you get to alpha n minus 1, alpha n, and that is equal to the second or the third coefficient over the first one. And it's the negative of that. No, sorry, the first one is the negative and the second one is not. Okay, so this one is not a negative. Okay. And this pattern actually keeps going down. So the sum of the triples, the sum of the quadruples. Okay, so basically each time you go down, this guy here increases by 1, so like more than 1 goes to it. So the next one might be alpha 2, alpha 3, etc., etc. Like it's a combination of them. So it increases by 1, and this guy here, it's going to change from positive to negative to positive to negative to positive to negative, and this number is going to go down by 1 each time. And what you'll end up with is the product of the zeros. So the product of the zeros, which is equal to alpha 1, alpha 2, alpha 3, dot, 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 times alpha n, which is equal to minus 1 lots of n. So depending on how many it is, if it's positive, so if it's an even number, then this minus 1 will turn into 1. But if it's an odd number, odd number of roots that you've got, or zeros you've got, then it's going to give you a minus 1. And that is of a over n over a n. Okay, and so that's the last one. So it's basically saying take the last term, the constant term, and divide it by the first coefficient, or the first term's coefficient. Okay, and as I said, I'll show you what this looks like with a quadratic. So let's say we have p of x is equal to ax to the power of 4 plus bx cubed plus cx squared plus dx plus e. So what you end up with is the sum of the zeros. So the sum of the zeros is alpha plus beta plus gamma plus delta. Okay, and that's equal to minus b on a. Then you've got the sum of products of pairs. So that is alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus delta gamma delta. And that's equal to c over a. So see how it swaps from being a negative to a positive, and it uses the next value, the next coefficient, next term, whatever you call it. Okay, then we've got the triples. So it's going to be alpha beta gamma plus alpha beta delta plus, now I've got to be careful, beta delta gamma plus gamma delta gamma delta alpha. And that one's equal to minus d over a. Okay, then the last one, because we have the degree 4, there should only be 4, and that is alpha, beta, gamma, delta, and that's equal to e on a. So again, negative, positive, negative, positive. Okay. So it's quite a mouthful, but it's just basically a pattern, and it's a pattern you can kind of see. Okay, so it's just, you add one more, and then you go to the next value. Add one more, go to the next value. So what we're going to do is we're going to have a look at this in action with another cubic. Okay, and this cubic is going to help us calculate some specific parts of these. So let's have a look at the first one. Let a, b, and gamma be the roots of the cubic equation, x cubed minus 3x plus 2 is equal to 0. Use the formulae above to find. So we're not actually going to factorize this and use, we are going to let me rephrase that. We're not going to factorize this to do it. What we're going to do instead is we're actually going to write out our values and calculate it that way. So first things first, before we even start, we're going to write a is equal to, b is equal to, why did you happen? C is equal to, and D is equal to. Okay, so remember that A is the term in front of the x cubed, or the coefficient of x cubed, which is in 1 in this case. B is the coefficient of the x squared term. Now, because there is no x squared, therefore B must be equal to 0. So it's equal to 0 there. C is equal to minus 3, and D is equal to 2. So those four are going to help us with all of these. So let's start off with A, alpha plus beta plus gamma. So this one's pretty easy. This is just the sum of the zeros, which is equal to B over, or minus B over A. So therefore, A plus, or alpha plus beta plus gamma must be equal to 0, because 0 over 1, which is that. Good start. All right, part B. Part B says we want the product of the 3, so alpha, beta, gamma. So the product of the zeros. Now the product of the zeros is minus D over A for a cubic, okay? We could do it the longer way just to guarantee, so writing the formula. So it's minus 1 to the power of n over A0 over AN, okay? So A0 in this case is the last value, so the last value along here. So it's equal to 2. AN is equal to the first value, which is 1. Now the n is basically how many terms do we have in our expression, and in this case it's 4. So 4 minus 1 times 1 times minus 1 times 1 means that we've got a positive, okay? And, oh sorry, it's not how many, it's the highest value, it's the degree. The degree is 3, so the 3 goes up here. So minus 1 times 1, minus 1 times minus 1 times minus 1 is equal to minus 1. So it's going to be minus 1 lots of 2 over 1, which is equal to minus 2. So the product of the roots, alpha, beta, gamma, is equal to minus 2. The sum is equal to 0. Okay, now C, we've got the product of the triples. Okay, so, or the doubles, sorry, the product of the doubles, or the sum of the doubles. So alpha, beta plus alpha, gamma plus beta, gamma. Now I know sometimes I actually have the beta, gamma and this around the other way mixed up, but it is exactly the same, okay? It is exactly the same. So this is equal to, now this one's C on A for this one. So my value of C is equal to minus 3. My value of A is equal to 1. So alpha, beta plus alpha, gamma plus beta, gamma is equal to minus 3. So those are the 3 easy ones. Now part D is where this starts to get a lot trickier. Now part D wants us to find the reciprocal of each. And the first thing you might want to do is say, well, why don't we just flip them all over, okay? Why can't we just go, okay, well, this is the same as alpha plus beta plus gamma, because we can just take the reciprocals of each one. Now, the question I want to ask you is, well, is that actually the same thing? If I said I had 1 over 2 plus 1 over 4 plus 1 over 7, is that the same as 2 plus 4 plus 7? Is that the same thing? And hopefully you say no, it's not the same thing. So we can't actually do this. We can only do the reciprocal when we have the equation, because we take the reciprocal to the other side, and that's what balances it out. So what we're going to have to do in this one, so we actually have to add these fractions together. So the easiest way to add fractions is we have the common denominator. So what we're going to do is we're going to multiply each fraction by the denominator of the other two. So for example, and I'll do it quickly over here, 1 over alpha times beta gamma over beta, that's meant to be gamma, gamma, like that, okay? So the reason we're doing this is because we want that common denominator, okay? So I'm going to write it over here. So 1 times beta gamma gives us beta gamma over alpha beta gamma plus, now this one is going to be alpha gamma over alpha beta gamma plus, and this one's going to be alpha beta over alpha beta gamma, just like that. And so that's going to give us the common denominator of alpha beta gamma, and on top we're going to have beta gamma plus alpha beta, which you will notice is the product on the bottom and the sum of the doubles on the top. So we've already calculated the sum of the products, and the sum of the products is equal to -3. So that's this value here. And the product is equal to -2. So this is equal to -3 on -2, which is just equal to 3 on 2. So therefore, 1 over alpha plus 1 over beta plus 1 over gamma must be equal to 3 on 2, just like that. Okay. Now, our next one is the square of the two. So a squared plus, or alpha squared plus beta squared plus delta squared. So this is E, which is alpha squared plus beta squared plus delta squared. Okay, so immediately you might be thinking to yourself, well, okay, why can't I just, make these equal to, why can't I just make these ones equal to, like just take each value and square it? Well, again, we don't actually know what alpha, beta, and gamma are. So what we can do is we can do the following. Now for this one, I'm going to say to myself, well, I know that if I take alpha plus beta plus gamma, so I just take the sum of these and I square them, what this is going to give me is it's going to give me some terms like this. But it's also going to give me 2 alpha, oh God, that's horrible. 2 alpha beta plus 2 alpha gamma plus 2 beta gamma, like that, okay? So this gives us part of what we want, okay, by just knowing that, well, an expansion of this is going to give me this thing here, but it's got something tacked on the end. What we can do, though, is we can actually take a factor of 2 out. Oh, God. We can take a factor of 2 out from here, and what we're going to be left with is the sum of the products, the sum of the doubles, okay? And we can work out what this side is, because this is just saying, well, this is just the sum of them, so this thing here, squared, so 0 squared. So alpha plus beta plus gamma is equal to 0, so this is saying 0 squared is equal to alpha squared plus beta squared plus gamma squared plus 2 lots of the sum of the products. Now the sum of the products is equal to, up here, -3. So we get 2 lots of -3 down here. So 0 is equal to alpha squared plus beta squared plus gamma squared minus 6. So 6 must be equal to alpha squared plus beta squared plus gamma squared, which is what we are after. Just like that. Okay, we're almost there. Last one, part F. So part F is another one of these tricky ones. Okay, this one's an even bigger collection of our symbols. So what I'm going to do is I'm going to write F here, and I'm going to put it in. Okay, so in this case it's going to be alpha squared plus, alpha squared beta plus alpha beta squared plus beta squared alpha gamma plus beta gamma squared plus gamma squared alpha plus gamma alpha squared. And that's meant to be an A, not an alpha, not an A. So alpha squared like that. Okay. So what we're going to do is we're going to look for some common factors of each of these. Now the common factors of each of these are, let me have a think really quick. A, B, winner. I'm just trying to think really quickly. Actually, you know what? We're going to leave it at that one there because I don't actually want to do this one. I can't think right now because I've been absolutely smashing videos lately and I am buggered. We are going to just leave that video there at this last one, okay? You won't be required to know how to do one of these ones because it actually involves an identity which we don't know how to use quite yet. And it's why I keep saying that I hate using this textbook as well because it uses stuff that I don't want to use. Anyway, with that being said, that's it. We're going to leave it at that one and we're going to have a look at factorizing some stuff in the next one. So I'll talk to you then.